looking where they go from today. So the only thing I want to review with you quick is,
So we don't have to know the disease.
oh yeah, you gotta know the diseases. I'm just telling you what, right over there. I'm just telling you what might be matching. You gotta know correlation to diseases.
It's like there's no.
There were some over there.
Oh, low. It says low. Increase.
This one says lab 2. Well, don't worry if you don't have a top. Just give me it with the date of today, and then the lab 2 will be for tomorrow. So that's okay. If you don't have the cover, just put today's date. I'll know it's today. What affects filtration? Someone in the back room still? Is Katie back there?
I'm right here.
Was Krista back there? Krista, are you back there?
Yeah, I'm back here.
Okay. So, and there's Patricia. Okay. Tell me what are 3 things that can affect filtration? The structures of the glomerulus and the Bowman's capsule. Okay. So if they get affected at all, like strep is an example of can damage the glomerulus and poke holes in it, and you're going to have proteins spilling out into your urine with the strep infection. So the structures, if they're damaged in any way, that can affect what spills out. And we'll go with less than 70,000 molecular weight. Both books say something different. I think Graf says less than 50, Strassinger says less than 70,000. So tell me what 2 pressures?
Hydrostatic and on-body.
So what's hydrostatic?
Is large 8 pounds.
Okay. And then someone over here tell me oncotic. What draws in water? Unfiltered proteins, example would be albumin, would draw in more water to keep that blood pressure through the glomerulus at a constant rate. Then tell me the 3rd system. The renin, angiotensin, aldosterone system in response to a low blood pressure or low sodium. Renin is produced by that juxtamedullary complex. It works on angiotensin 1, becomes angiotensin 2 in the lungs, and which releases aldosterone. What does aldosterone do? Reabsorbs more sodium, which draws in more water, which keeps the blood pressure in the glomerulus constant. What other hormone is affected that helps you reabsorb more water? ADH. Okay, so aldosterone helps you reabsorb more sodium. ADH helps you to reabsorb more water. Okay, so tell me what is
Was that absorbing more water? Aldosterone?
ADH. Tell me what is absorbed
Oh, okay.
passively in the PCT, descending loop of Henle, ascending loop of Henle, distal, and collecting. Where is water?
Is in PCT.
Everywhere but where?
AC.
So do that first. Then what 2 other substances are passive?
Urea in the PCT and urea and sodium in ascending.
Okay. So urea and sodium. So I think those are going to be your 2 hardest passives. To remember that. Okay. So what is on this side of the room, what's in the active on the PCT?
Sodium chloride, salt.
Salts, so sodium chloride, I just had you know, so that would be salts. What's a heavy molecule that should be reabsorbed that is active? It affects the renal threshold of a diabetic, why it's spilled over.
Glucose.
And then you can't reabsorb it because it's reached its level of saturation. Okay, and there's one other substance. Glucose, one other substance, and the salts.
What is D on the?
Amino acids.
Amino acids. Anything reabsorbed and actively on the distal. Or descending, no, anything on the ascending.
Yes, so chlorine,
And anything on the distal. Okay?
Jen, is that for the distal, the descending, the
This is
urea water?
descending loop of Henle. Ascending loop of Henle, distal, and collecting. I had ascending is the urea and sorry, this is my bad. I wrote them on the wrong loop. So that's how it should be. Okay, so you're gonna have to fill in a chart for that. Okay? And then tell me what is reabsorbed, what is not secreted but reabsorbed to maintain the 7.35 to 7.45.
bicarbonate.
The bicarbonate. And then what two substances are secreted in the urine that get rid of excess hydrogen, makes your urine more acidic?
Phosphate ion and ammonia.
Ammonium. Okay? So you're going to have to know that. That's the biggest piece from that PowerPoint. Okay? Physical, you know, is the color, the clarity, the specific gravity, and, you know, you can do it refractometer versus. Tell me, how do you correct for the refractometer if I have 1.030 and I have 1,000 milligrams or 1 gram of glucose and 1,000 milligrams or 1 gram of protein?
Glucose, you subtract 0.004, and protein is 0.003.
So what are you going to report to the physician? This is a person's urine.
0.027 and point.
No.
Oh wait. What?
They have both of these in their urine. What are you going to report to the physician?
So that one is the main number right there for.
This is what you got on the refractometer.
1.0.
This is subtracted for the glucose. This is subtracted for the protein. So what are you reporting?
1.0.
So wouldn't it be 27, not 23, if you're
30
subtracting?
minus 0.004 is 26, right?
Yeah,
Yeah.
but for the protein, you
Is
subtract it.
6 minus 3
Why would you
is
subtract it from
20.
the glucose when you subtract it from the original?
Right.
If they're both in there, you'd have to take into account both.
So we'd be subtracting
0.007, 4 and
If they're
3.
both a gram or more.
Okay, so
But-
if it was separate, then you would subtract,
Yes.
but because they're together.
If it was together, it's both. But if I just said, this man's urine had glucose, you'd report this. And then if I had patient 2 had 15 and they had the 1,000 of protein, then what would you call for patient 2? If they're separate.
Okay, but if they're
If they're
together.
separate, then 4 for the glucose, 3 for the protein. But if a patient had both, it's minus 0.007
So
to
you would
correct.
subtract the glucose first. Then
doesn't
the protein.
matter.
It doesn't matter.
Subtract the 3 for the protein, then go subtract the 4 for the glucose. That doesn't matter. If it's a patient with both. Now, are you understanding what you do if it's 500 milligrams, which is 0.5 grams, then you split that in half. Okay? So So then you'd subtract only 0.002 for glucose if it was 500 milligrams, and this would be 0.0015, and I'd be okay if you just subtract 0.001. I'm not gonna make you subtract the 1.5. Just do, if it would be 500 milligrams, which is half a gram, then you divide those 0.004 by 2 and 0.003 by 2. Okay? So why would you subtract 4 and 3 if it's not a full gram? So if
You're
it's,
asking like
if,
750
does everybody get that if it's a full gram, if it's 1,000 milligrams, it's a full gram.
Right.
You subtract for glucose that, and for protein this. Is everybody okay with that part?
Yeah.
Then if it's half of that, 500 milligrams is 0.5 grams, you can't subtract the whole amount, so you cut it in half.
So
Okay.
it'd be
It'd be
point
0.002, and that was 0. Okay.
But I'm okay if you just subtract 0.001 on protein. I'm not gonna take off if you don't have it carried out to 4 decimal place. So is everybody okay for half or a whole gram? Because often you're gonna get 500 milligrams, not 1,000 milligrams. That was unusual with your dad to have 1,000 milligrams. Okay, yes.
What if you had like 700 or something?
I won't give you that.
Okay.
It'll be 500 or 1,000. Okay? It, probably if it's between like 250, they're probably not gonna figure it's gonna affect the refractometer that much. They probably won't do anything. And 750, if it was 750, what would I do? 0.003, and here it'd be, 0.002. Something like that, if it was 750. But if it's less than 500, they're probably not gonna think it's gonna affect the specific gravity that much to even take action. But you should be aware of that, especially for the registry, that you gotta correct. Okay, so what we'll do tomorrow, we'll take the test first, and we're gonna do then renal disease states and some test methods. Then we're gonna do lab, then we're gonna break for lunch, then we're gonna do amino acidureas. Okay? So that will be our goal for tomorrow. And I'm sorry you guys already look like, ugh, it's only the 3rd week.
So for the chem strip, you just run the chem strip analyzer, just clean it, strip wherever, and train with water.
If you are the person getting that machine ready, it has to be completely ready that you turn out accurate results before you run patients. So what do you all do to the chem strip analyzer to make sure it's ready to run patients and you trust that they're accurate?
Calibration.
Okay, clean it first. And what's the first thing you do after you clean it?
Calibration.
Calibrate it. If the calibration isn't in, you gotta figure out, clean it again, do other strips before, you gotta get that calibrator in before you do QC. It's pointless doing QC if it's not calibrating right. Something is not reading correctly in the reader if it doesn't give you that set of numbers. And those numbers, if you look closely, are very close in range. Okay, they're very close to each other. Then what do you do next? We got it calibrated. You run level 1 and level 3. Level 1 should have the proper analytes that are abnormal. Level 3, I think the only thing we really circled on level 3 was the specific gravity, I'm pretty sure. What I should have did is ran them a few times, then came up with a new range, because I think we circled a ton on the abnormal control. I think we had more than just the specific gravity. Technically, are those controls good enough to turn out patients? No, because we had certain ones that didn't match the range. So you would have to take action. Redo your QC, develop new ranges at the top of your sheet, then rerun them till they come in. Sometimes we go, you always try a control a second time, then you dilute new controls if you know your range is valid. So that's all called troubleshooting, but that's something you have to be able to do. Clean, calibrate, make sure your QC is all in on 2 levels. Then you know you're good to run your patients. So that's what I was kind of expecting on the chem strip analyzer, okay? Okay, so we'll start with that tomorrow and then go from there.